Here we need to find the area between these two curves. We're going to find the area bound by these two curves, the area that these two curves cordon off from the whole rest of the coordinate plane. Well, the first thing we need to do is we need to figure out where the two curves cross each other, so we're going to set them equal to each other and solve it. When we do that, you'll notice that we have our x squareds dropping. Then we could factor it, pulling out your greatest common factor of 3x, and it leaves you with difference of squares, so you know it crosses at a -2, a 0, and a 2. Now that does match with the graph over here. Now you probably don't have the graph on your paper, but feel free to go ahead and graph it on your calculator. That way you can actually see if your answers of where they cross make sense. You can also then go ahead and see which function's on top and which one's on the bottom, because you need to know which function's on the top and which one's on the bottom for the sake of integrating. When you're looking at this first part here, you'll notice it's the cubic function here in black that's on top over here. So you're going to integrate from a -2 to a 0, because that's from here to here, with the cubic function on top minus the quadratic here on the bottom. Cubic function minus your quadratic, which you'll see does simplify down a little bit. Once again, your x squareds drop. Then we need to go ahead and figure out this area over here on the right. So you're going to go from a 0 to a 2. So we're integrating from 0 to 2. You got to take the top function, which is your parabola, minus your bottom function, which is your cubic. So you got to take your parabola minus your cubic. And by the way, when you collect those like terms, once again, your x squareds drop. Now you need to go ahead and integrate each one of these. You integrate this, you got to go up to an exponent of 4, so you're going to have a 4 down on the bottom and front to undo that. Integrate that from 0 to -2. You plug in 0, subtract what you get when you plug in 2. Similar type of thing over here. Now you got to plug in 2, subtract what you get when you plug in 0. And so then we end up with just plain old normal 24. Okay, so we're going to go ahead and find our area bound out by this curve right here in the first quadrant. Notice they cross at the origin, and then they cross over here. You may assume that's 2, but it's not. So to find out where they cross, basically you could set these equal to each other and try to solve it, but it's not going to solve nicely. What you want to do, though, is you want to take your two functions, this one here, go to your calculator, put it in your y equals. Put those in your y equals. Then you want to hit math. Once you hit math, hit your up arrow once to solve. It'll bring up a screen similar to this. What you have right here may look a little bit different, but that's okay. Hit your up arrow once. Then we want to type this in. Because for the most part, when we look up here, we want to set these equal to each other, and it's really going to be this function minus this function to give us 0. And that's what we're telling it to solve for, is our first function minus our second function equal to 0. So here you want to go to vars, y vars, function, select y1, then go subtract, go back to vars, y vars, function, select y2, then it's going to bring up something similar to what we have up here. Now your cursor should be down here where the x is. We knew from looking at the graph that it crossed near 2, so put a 2 here. Then you need to tell it to solve. Solve is alpha enter. When you hit alpha enter to solve it, it should give you this value right here. Now, nice long messy number. We're going to use that on our calculator, so instead of going ahead and writing it out each time from our home screen, we're going to go ahead, hit X, because that's what X is this number here, hit store, which is down by the on button, and we're going to store it as A. When we do that, whenever we type a the next time, it's going to use this value here. I'm going to actually use that in my problem. So instead of writing out this long number here, because you know you got to integrate from 0 all the way over to that long messy number, I'm going to say a is that number. So I'm going to integrate from 0 to a. Then you got to take, once again, your top function minus your bottom function. Yes, you could go ahead and integrate this one by hand, or you could type it in. If you did it by hand, you get u du, and I'm talking about integrating the first part here. You'd have to use a u substitution here that we're talking about over here. Well, when you get done integrating that, then you'll get this. Well, you'd also have to integrate this. That's pretty easy to integrate. When you integrate that, you get this. And then all you'd have to do is plug that messy number in, subtract what you get when you plug in 0. And you would get this. However, an easier way to do it is to go to your numeric integration. So go back to math, hit enter twice, brings this up. Now we're really integrating, once again, our first function minus our second function. That's what we had written right here, our first function minus our second function, because we put those in our y equals. To get the y1 and the y2, once again, go to vars, y-vars, function, and so on. Go comma x, because you're integrating with respect to x, comma 0, because that's your lower bound, comma your upper bound, which is a. Type that in, and you get this, and that's a much easier way to do it. Now we're going to extend this just a bit. We're going to say, okay, let's take this shape here, and we're going to go ahead and rotate that shape about your x-axis, about this green line I just drew. In other words, this shape here is going to come out of the screen towards you, rotate back in, down through the back of your screen, and back up. It's going to form kind of a donut where it's open in the middle on this side, but closed on this side here. If you were to slice this donut, it would really look like a washer. And to find the area of a washer, you do the area of the big circle minus the inner circle. And it'd be a bunch of these washers added together. Well, when you add a bunch of things together like that, that's just your repeated sum. So you're doing your integral. So once again, the volume of a washer is the big radius in circle minus the small one. And then you got to have your h. Your h, or your thickness, is your dx. So you're going to go pi, the big radius, which is your top function, all squared, because it's your radius squared, minus pi, your small function, all squared. And then just type that into your calculator like we did on the last problem. And you will get this. Now, a third extension we're going to do, a third extension is basically we're going to take our area, we're going to cut it like this. It's going to make a line. That line's going to be the bottom of a square. So you're going to come up this same distance, off the screen, over and back down. It's kind of hard to show you here. And then same idea here. This would be the bottom of a square coming straight out at you, coming up, going over, coming back down. This would be a square here coming straight out at you, with each side being this length, and each side being this length here, and so on. It's going to form a shape. Now all you have to do is add together all those squares. To find the area of a square, all you'd have to do is square one edge. To find the length of one edge here, you take your top function minus your bottom function. That's your vertical distance here. To find the area of one square, you'd have to actually take that distance and multiply it by itself again, or square it. But we're really trying to add all these squares up all the way along here, so that's your integral from a to, or 0 to a, with respect to x. Once again, then you would want to go ahead and type that into your calculator, and you would get your answer.